Hello everyone, myself Ruchita, studying in Sri Venkateshwara College of Engineering, 6M CSE. Today I am here to talk about the subject Computer Graphic and Image Processing. The topic is graphic function. Coming to the introduction, a graphic function is a mathematical relation that maps each element of a set to exactly one element of another set. Graphs of function can be represented visually to show that the relationship between input and the output values. Graph functions are commonly used in fields such as mathematics, computer, science, and engineering. So here are some graph functions that is linear, quadratic, rational, and logarithmic. Next, coming to the types of graph function. Common types of graph function include linear function, quadratic function, exponential function, and trigonometric function. Each type of function has a unique graph that represents its specific characteristics. Understanding the shape and behavior of the different types of functions is essential for analyzing data and solving problems. Coming to the linear function. Linear function have a constant rate of change and graphs as straight lines. The general form of linear function is y is equal to mx plus b, where m is the slope and b is the y-intercept. The graph of a linear function is straight line and extends infinitely in both directions. So here is the example of a linear function. That is, in linear function the values will be constant and it will be extending. Coming to the quadratic function, quadratic functions have a squared terms and a graph as parabolas. The general form of a quadratic function is y is equal to ax square plus bx plus c, where a determines the direction and width of the parabola. The graph of a quadratic function is symmetrically curved with a vertex at a minimum or maximum point. So here, when a is greater than 0, parabola will open up, and if a is less than 0, parabola will open down. And if a is like the value of the a is bigger, then the parabola will be thinner. If the value of the a is smaller, then the parabola will be wider. Coming to the exponential function have a constant base raised to a variable exponent. The general form of an exponential function is y is equal to a to the power x, where a is the base. The graph of the exponential function is a curve that either increases or decreases exponentially. Depending on the value, the graph will change. So graph of the exponential function of y is equal to 2 to the power x. The value of x is increasing, so it is moving in an upward direction. Coming to the trigonometric function. Trigonometric function involves ratios of the sides of a right triangle and are periodic. Common trigonometric function include sine, cosine, and tangent. The graphs of trigonometric function exhibit repetitive patterns over specific intervals. Coming to the trigonometric function, sine is opposite by hypotenuse and cos is adjacent by hypotenuse, tan opposite by adjacent, cosecant hypotenuse by opposite, and secant hypotenuse by adjacent, and for cot it is adjacent by opposite. Coming to the transformation of functions. Functions can be transformed through translation, reflection, stretches, and compressions. This transformation alters the shape and the position of the original function's graph. Understanding how transformation affects function is essential for graphing and analyzing complex functions. Coming to the transformation of functions, for translation, g of x is equal to f of x minus h plus k, horizontally h units and vertically k units. For reflection, for g of x is equal to minus f of x, for this it will be reflected in x-axis, and h of x is equal to f of minus x, it will be reflected in y-axis. For dilation, g of x is equal to c f of x. If c is greater than 1, it will vertically stretch by a factor of c. If 0 is less than c and c is less than 1, it will vertically shrink by a factor of c. And if h of x is equal to f of k of x, so if 0 is less than k and k is less than 1, it will horizontally stretch by a factor of 1 by k. And if k is greater than 1, it will horizontally stretch by a factor of 1 by k. Coming to the composite functions. Composite functions are formed by combining two or more functions. The output of one function becomes the input of another function in a composite function. Composite function can be graphed by applying the operations of each function in sequence. Composite function is formed when one function is substituted into another function. For example, f of x is equal to x minus 5 and g of x is equal to 3x plus 8. For f of g of x, we have to take f of g of x value. In the place of x, we have to substitute g of x, that is 3x plus 8 and the minus 5. So f g of x will be 3x plus 3. Coming to the inverse function. Inverse functions undo the effects of the original function. The graph of an inverse function is a reflection of the original function over a line y is equal to x. Inverse function switches the input and output values of the original function. The reflection over the line y is equal to x, switching the x and y coordinates. Coming to the applications of graph function. Graphic functions are used in real-world applications such as modeling physical phenomena, analyzing data trends, and optimizing processes. In engineering, graphic functions help visualize and solve complex problems in areas such as circuit design and structural analysis. In economics, graphic functions are used to model supply and demand curves, cost function, and revenue functions. Coming to the graphic technology, advances in technology have made graphic functions more accessible and efficient. Graphic Graphing calculators, computer software, and online tools allow users to graph complex functions quickly. Technology enables students and professionals to visualize and analyze functions in a dynamic and interactive way. Coming to the graphing tools. Common graphic tools include Cartesian coordinates systems, polar coordinate system, and 3D graphing software. These tools provide different perspectives for visualizing function in two-dimensional and three-dimensional space. Understanding how to use graphic tools effectively is essential for accurately representing function. In the four coordinates, in the first quadrant, x and y, both the values will be positive. In the second quadrant, x-axis will be negative and the y will be positive. In the third quadrant, both the x and y axis will be negative. And in the fourth quadrant, x-axis will be positive and the y-axis will be negative. So, best practices for graphing function. And graphing functions ensure that the axes are labeled with appropriate scales and units. Use different colors or lines to distinguish multiple functions on the same graph. Include a legend or a key to explain the meaning of each function or a curve on the graph. So there are three different graphs, that is rational, exponential, and logarithmic. For rational, it is f of x is equal to 1 by x. For exponential, it is f of x is equal to 2 to the power x. And for logarithmic, it is f of x is equal to log x. Coming to the challenges faced in graphing function. Graphing complex function with multiple variables or parameters can be challenging. Interpreting graph accurately requires attention to details and understanding of mathematical concepts. Identifying difficult points, asymptotes, and other features of functions graph may require advanced analysis techniques. Coming to the conclusion, graph functions plays a crucial role in mathematics, science, and technology. Understanding the properties and behavior of different types of functions is essential for problem solving and decision making. By visualizing functions graphically, we can gain insights into patterns, relationships, and trends that may not be apparent from numerical data.